Okay, we'll start with Fernando on genomic prediction of meat tenderness. Next week we have Kelt.
Oh.
Yes.
Okay. You should send me a reminder.
It might be this week.
Yeah.
Okay.
So my name is Fernando Bertolotto, and my advisor here is Professor Andy Rosa, and I'm talking about genomic prediction of meat tenderness using Bayesian regression models. Sorry. And you're talking about livestock production in Brazil, thermal comfort in cattle, the carcass quality in Miller, selection criteria in Brazilian beef cattle, animal mixed models, genomic analysis, and you're talking about futures that give these results. So, Brazil has more than 212 million of animals that produce more than 10 billion of tons of meat, and about more than 2 million tons of this production are exported for more than 200 countries. So, Brazil is the largest export of beef cattle in the world currently. Yeah, this is probably because in our region is the produce more beef cattle in Brazil. This is our region that we work. Another interesting detail that in our region, the temperature and humidity index, that is a measure of thermal comfort in cattle, is considered normal, and the vegetation of grass in this location, in these regions are very good. And another interesting detail is that we have just two seasons, dry and wet, over the year. And why we are the largest producer of beef cattle, but we can't produce beef cattle, tender big meat. Probably, of course, there are many sources of variance that affect beef tenders as pre and post-mortem factors. But why? What is the problem? Probably it's a historical. I don't think it's the problem, but along the years, these animals have selected for growth traits as pre and post weaning weight, and fertility as age at first calving, stayability, scrotal perimeter, maternal ability, carcass quality, and feed efficiency as the weight. All these traits have been selected along the years. We don't have selected these animals for meat tenderness before. So all these traits have been analyzed using animal mixed model with pedigree information, and we always work with two models: complete models and reduced models. But we fit the fixed effect as contemporary groups, as management, environment, social variation, and age of genetic counting. We also fit maternal effect, maternal environment effect, and this is what we have to predict is the epigenetic effects, the breeding value of it for the animals for this trait described before. And we also use the same approach, animal mixed model, to try to predict the genomic animal breeding value for meat tenders. We use the contemporary group as year and day of slaughter and sex as fixed effect to try to predict the additive genetic effect for this trait. So this is our results using this quantitative genetic analysis, and we found an editability about 0.14, but when we try to predict the breeding value, almost all values was closer to zero. We can predict it using this approach. So I think in 2010 we changed the fonts. We don't work more with quantitative was to compare the accuracies of different Bayesian regressions model in predicting molecular breeding values for meat tenderness in bull and lean cattle. Before to start the materials and method, I need to talk about why this work was made. 20 years ago, the owner of Guaporé Pecuária, Grant, and other people noticed that some bulls, some steers had project with tender meat. Then they designed an experiment using 14 Miller, 2 Aberdeen Angus, and 2 Brahma. They used USDA meat grades to see if there is or no animal that present this trait. So the question is, this animal can be produce really meat, tender meat, and this was our results. We have 3 steers that produce projects with here meat your choice, 2, 1 meat prime and choice, and here again choice. The aim of this project was to produce just choice, so they can see that really these animals can produce meat choice. This was our best results. After that, they performed two maintenance using steers that the pedigree was low, and unfortunately, I think half of this dam there is a pedigree no. Okay, and then the third mating was made using principle of identical genes by distant to ancestor founders. Here, what we done, we use the higher steers with higher dams that for genetic potential for meat tenderness, and the lower steer with lower dam with genetic potential meat tenderness. We make it because we need to create a segregated population with animals with less meat tenderness and animals that present lower meat tenderness. So we have in the first, second, and third mating 207 animals, 142 animals, and 83 animals in this data set. Unfortunately, as you can see, we have 142 animals in the second mate, but actually you can just genotype 36. So all this analysis was made using 326 animals. But yesterday I received an email that the others animals, 106 animals, was genotyped. And I think in this week there we start again this analysis including this animal. Here, 63 animals were genotyped in AG sheep and 262 in JGP sheep. The sheep is specified for Bos indicus, and we make some features of quality controls. The first one was excluded. Is need located with redundant position and located in X, I, and mitochondrial chromosome. We remove all these SNPs. So remaining only 740K SNP. So as we need to make imputation because we work with 2 different densities of ships, we need to know if all these SNPs in JGP ship are in this AG ship. So as we exclude or remove this SNP, we can work now with this number of SNP. So the first filter of quality control that we used was related to coverage. We exclude all this SNP with presented coverage less than 90%. Here in AG sheep, separately in each. So we make an after that we need to make an imputation. I use f input, and we use to improve the accuracy of this analysis, this imputation. We use 33 SERs. It was genotyping age shift. All this SER was parents of these animals used in the experiment. And after that, we make more two filters of quality control. Here we exclude all SNP that present hardware equilibrium equal 1 and less than 5% corrected for local running test. And this is very interesting because when we have errors objective genotyping, when we plot heterozygous versus hardware equilibrium, we can see this is an error of genotyping. And after we perform this filter, all this SNP with error was excluded. Okay. The next one is the quality control for minor allele fragments that we exclude all SNP with MAF less than 5%. And of this initial inputted data set remaining after all this quality control remaining just 345K SNP. We make all this analysis using this new data set. So in genomic selection, we use the 5 Bayesian regression models: ridge regression, Bayesian lasso, Bayes B, Bayes A, and Bayes C pi. We make several adjusting this trait. The first one was adjust for the sex of this animal because we have 332 males and just 94th male. The order of this slaughter, and we also adjust for the first 3 principal components from kinship. All this adjust of phenotype was made when we run which one these jobs, and cross validation was made using the leave one out method. And when you perform each one of these jobs, we drop or we remove one animal, so we can make it this 326 times here. And after discovering what is the best model, we need to run again for 12 times using 2 approach: select SNP equidistant 2 by 2, 5, 10, and select SNP based on p-value for 2 ones. So we need to do this because we want to know if it's possible work with less SNPs without decreased accuracy of genomic prediction, and of course to create a personalized. So we work with VGLR package, and I just can't finish this research because I use the Condor system, and it's very interesting. I've gotten over 17,000 computing hours since I started my analysis using Condor, which is more than 80 years. So I can finish this in 3 weeks. This is very interesting. And as a result, and as we create a segregated population, we can observe high variability for this trait. Then, this is the results of genomic selection. And here we can observe that Bayes B was the best model that can be used here. And here you have the based on p-value, the best result was when we work with 69K SNP here. And when we work with equidistant SNP, the best result was when we work 2x2 SNP select. And the next steps is to perform the fourth method, to predict molecular ingredient value for abscess, and we will use the Bayesian model with the markers will be selected using p-value. And this is the genomic values for the SIRS, powers of this project, and we will work with these 6 SIRS again, the accuracy we use in cross-validation was 0.24. Now we'll make, I think, the next, I don't know if it, sorry?
Can we go back to the previous slide for just a second?
This?
What's the units on the, or the units
KGF.
on the,
KGF.
on the x-axis, as far as those values go?
Here?
Yeah.
Yes, KGF.
Oh, kilograms per.
Yeah,
okay,
kilograms
all right.
And here, then the first step will be using these SIRS. Now we know the pedigree of SIRS and the pedigree of dams. We will perform this mating to discover if these animals can be present in their pit. So this research was performed using the computer research coder. And I would like to take it to Laura Mitchell and Christina Koch for all assistance about the use of coder. I'd like to take to Professor Guilherme